Integration by parts. First thing I think we should do is derive the formula. Instead of taking derivatives, we're going to take differentials. We're going to look at the product uv. We're going to take the differential of uv, which is the differential of the first times the second plus the first times the differential of the second. Pretty much the product rule. And I'm going to put the du at the end. So this is v du plus u dv, and this is the differential of uv. And now I am going to take or denote that I'm taking the integral of both sides. So I'm going to take the integral of the left side. Remember, the integral over sum is the sum of the integrals, so I can do that. Now, the integral of duv is just uv. It's just uv. And this is equal to the integral of v du plus the integral of u dv. And what we want to do is just solve for this. That is, bring that to the other side. So the integral of u dv is uv minus the integral of v du. And that is the integration by parts formula. And any time that I ever forget it, it's not a big deal. I could remind myself of it by doing this. Okay, so that is the integration formula for parts. Now, I'm going to show you, I'm going to do about 5-6 integrals, and then, believe it or not, I'm going to do them again, showing you a much quicker way of doing them. Hopefully your teacher will allow their easier way. So here, I'm going to let u equal x. So that means that dv is everything else, e to the x dx. So du will be just 1 dx, and v, the integral of this, would be just e to the x. So the integral is going to be u times v, I'm copying the formula, u times v, x e to the x, minus the integral of v du. v du is dx. And that integral I can actually do right here. X e to the x minus the integral of e to the x is e to the x plus c. So if you like, you can factor out the e to the x, but there's your answer. Pretty quick. Not the worst problem there is. Now let us try another one. Suppose you have the integral of x squared ln of x dx. Now remember, say you call this u, then what's left over is dv. And you better know how to compute the integral of dv. And I don't. So I'm going to let u equal ln of x. So then du will be 1 over x dx. And if this is u, then everything left over must be dv. dv must be x squared dx. But I know what v is. It's x cubed over 3. So this integral is equal to u times v, x cubed over 3, ln of x, minus v, and we'll put the 1/3 in front, minus v du. And du is 1 over x dx. So what I get is x cubed over 3 ln of x minus 1/3, and this simplifies to x squared dx. So I get x cubed over 3 ln of x minus 1/3. This integral is x to the 3 over 3 plus a constant. I will multiply top and bottom here by 3. So now I have a common denominator. And I can factor out x cubed from the top and 3 squared from the bottom, which is 3. And I'm left off with literally everything I didn't circle, like the 3, the ln x, the minus, and the 1, plus c. That's one way of writing that answer. Okay. How about we try this one? The integral of ln of x over x dx. So you're going to call something u and something dv. And whatever you call dv, you better know how to integrate. This is why I'm going to let u be ln of x, because I don't know how to integrate ln of x. So what's left over, dx over x, yeah, I know how to integrate that. That's just ln of x. And du is 1 over x dx. Okay, so this becomes u times v. That's interesting. But then again, I saw that come in. U times v, which is ln of x squared, minus the integral of v, ln of x, times du. Times du, which is 1 over x dx. And if you notice, this integral is exactly this integral. So I'm going to pass this over to the other side. And then I get 2 times the integral of ln x over x dx. This is equal to ln of x squared. But I was only asked to find out what this is. Oh, you mean you don't want 2 of them? Fine. You're a headache. I'll divide by 2 for you. So ln of x over x integral dx is ln of x all squared over 2 plus c. That is that integral. Now, suppose you have this one. The integral of x squared cosine x dx. I know how to differentiate x squared. I know how to integrate x squared. I know how to integrate and differentiate cosine x. So it doesn't matter what I call u or dv. I'll let u equal x squared. So then dv is what's left over. And du will be 2x dx. And v will be sine x. Almost never do you need to worry about saying like plus c. Once in a while, it will really be helpful to say, plus 7. But for the most part, it's not going to come up. Okay, so this integral is equal to u times v, x squared sine x, minus the integral of v du. I'll pull out the 2. So sine x, x dx. Well, looks a little bit better. I no longer have x squared. I just have x. In fact, it's probably better that we did let u be x squared. Because if I let dv be x squared, then we would have x cubed over 3. Okay. So the answer is going to be x squared sine x minus 2 times whatever this integral is. So on the side, let's do this integral. Let's evaluate this integral. And we're going to do it by parts. Let u equal x, then dv is everything left over. Du will just be dx, and v would be cosine x minus. But that's not how you write cosine x. Okay. So this is going to equal to u times v, which is negative x cosine x, minus the integral of v du, minus cosine x dx. But this integral, we know, this integral is sine x, this integral. So this is what I put up here, minus cosine x plus sine x plus c. So let's clean this up a little bit, distribute the 2, combine like terms. We have x squared sine x plus 2x cosine x minus 2 sine x plus c. And there is your answer. Notice we had to do integration by parts twice because this were 2. If it was 3, we would have had it done integration by parts 3 times. If it was 4 times. Gets pretty messy using this method if the power of x is larger than 2. I mean, even 2 was a mess. Okay. Let us try this one. Suppose you have the integral of cosine x e to the x dx. If I let u equal to cosine x, then du will be minus sine x dx. And dv is e to the x dx, so v will just be e to the x. By the way, I should be saying, can I make substitutions? If I call this u, will what's left over be du? Doesn't look like it. If I call this u, what's left over, will that be du? Don't think so. Integration by parts. So this becomes u times v, which is e to the x cosine x, minus the integral of v du. But that has its own minus sign, so it becomes plus sine x e to the x. Sine x e to the x dx. So the answer is going to be e to the x cosine x plus whatever this integral is. Let's do that on the side. It's very similar to the first one, to what we started with. Now, you could have let u be e to the x, and then down here for the next integral, you should let u be e to the x. That's fine. But we let u equal the trig function. We better let u equal the trig function here. Be consistent. Du will be cosine x dx. dv is what's ever left over, e to the x dx. So v is e to the x. As an experiment, so you can see what's going on. Actually, in the first time, call the trig function u, and then in the second integral, let u equal e to the x, or vice versa, and go back and then let u in the first integral be e to the x, and in the second integral, let u be the trig function. See what happens. Okay, this is equal to uv, which is e to the x sine x, minus the integral of v du. V du. E to the x cosine x dx. So I'm going to take this, I'm going to put it up here. E to the x sine x minus the integral of e to the x cosine x dx. And then I'm like, you mean I have to do integration by parts again? No, no. This is equal to the original integral. If I call the original integral I, actually let me not call it I. You have cosine x e to the x dx. You bring this to the other side, so now you have two of them, and it equals this. E to the x cosine x plus e to the x sine x. So therefore, the integral in question is equal to the right-hand side. I'll erase that plus sign in a moment. All over 2. Okay, we got twice what we wanted. Now, I'm going to go back. So that kind of finishes half of this video. Here we formally did our integration by parts, 100%. Just so I don't miss any, I'm going to come back. I'm going to do the same integrals all over again. But this time, I'm going to use a different method. I'm going to use a different method. Okay. So, we have their answer in front of us. Oh, actually we don't. Okay, so let me finish this up. This is already done. It's x cubed over 3 ln of x. This here is just the integral of x squared dx with the negative third in front. So we get x cubed over 3, which will become negative x cubed over 9 plus c. I'll show you how we can get that answer much more quickly. Now, I know how to differentiate ln of x. And I know how to integrate x squared. So, I'm going to keep integrating, differentiating on the left, differentiate on the right. The derivative of ln of x is 1 over x. The integral of the x squared is x cubed over 3. Once I know how to integrate that product, I stop. The answer is going to be positive this product, ln of x times x cubed over 3, minus, the signs alternate, plus minus the integral of that product. The integral of 1 over x times x cubed over 3 dx. So the ln of x times x cubed over 3, that's done. I can pull out a 3 here, and x cubed over x is x squared dx. But that integral is straightforward. That integral is straightforward. So let's not forget what's in front. Ln of x times x cubed over 3 minus a third times this integral is x cubed over 3. So I get, I'm going to say the x cubed first here. So you get x cubed ln of x over 3 minus x cubed over 9 plus c. Exactly the same answer. Okay, so let me just erase most of this don't want to erase the answer. We have the answer right here. It's ln of x quantity squared over 2. ln x over x. ln of x over x. Okay. So dx. I don't know how to integrate ln of x. So I'm going to put ln of x here because I know how to differentiate it. And what's left over is 1 over x. Remember, this integral is ln of x times 1 over x dx. I pick one part to put under d, and I take the other part to put under I. The derivative of ln of x is 1 over x. The integral of 1 over x is ln of x. Okay, now here's something really cute. This product, which is ln of x over x, and since I'm going across, I have to integrate. That's exactly what I started with. So the integral of ln of x over x dx, remember, plus minus. It's this product, which is ln of x squared, minus this integral, which is 1 over x ln of x. But that's this. If I bring this over, I get 2 times ln of x over x dx. The integral is equal to ln of x squared plus c. Well, I divide both sides by 2. Look at this. I got the same answer. Let us try this one. Just trying to figure out what that power was. Looks like it was x squared. The integral of x squared. And our final answer, I take it, our final answer is right here. And we did a lot of work for this problem. This is equal to x squared sine x plus 2x cosine x minus 2 sine x plus c. I'll show you how easy this integral is. It's always good to differentiate the term that's going to go to 0. You got x squared, 2x, 2, and 0. And ignoring for the moment cosine x, when you integrate it, you get sine x, integrated, you get cosine x. It's going to keep oscillating. The integral of cosine x is sine x. The integral of sine x is negative cosine x. And the integral of negative cosine x is negative sine x. Now, we stop here because when I go across, it's 0. The integral of 0 dx is 0. The integral of 0 dx is 0. For example, you can pull a 0 in front and you have 1 dx, so you get 0x, which is 0. Okay, it's plus c. But when you get to 0, you stop. So it's going to be plus this product minus that product plus that product. Okay? So it's x squared times sine x squared sine x, minus this times this, which has its own minus sign, so it becomes plus 2x cosine x, plus that, 2, yeah, that was a minus sign there, right? Yeah, so it should be minus, excuse me, minus 2 sine x plus c. Look at that. Every detail, everything, exactly the same. Same exact answer, and I did some tic-tac-toe. Once you get to 0, that's great. You can stop. Okay, so picking this to put under D, that was pretty good, because eventually I'll get to 0. Okay. Let us do this one. And there's the answer right here. That is the answer. And the integral is cosine x e to the x dx. Now, none of these are going to go to 0. You can take the derivative of that or the integral of that all day long. You'll never get 0. You can integrate this forever and ever, or differentiate it ever forever, and it'll just stay e to the x. So we just have to stop when we get that same integral, or a multiple of it. So you have d and you have I. I'd rather take the derivative of a cosine function of these trig functions, because I know the derivative is better than I know the integrals. And I know the integral and the derivative of e to the x pretty well. Okay. The derivative of cosine x is negative sine x. The derivative of negative sine x is negative cosine x. That's when I'm going to stop. That's going to be the same integral. So this is going to equal plus minus plus. It's going to be plus that product, cosine x e to the x, minus this product, which already has a minus, so it's plus sine x e to the x, plus, actually, minus the integral of cosine x e to the x dx. But that's exactly this. You bring this here to the other side, and now you're going to have 2 of them. But I don't want 2 of them, so I'll divide by 2. And there's my answer. Exactly what I have there. Fine, it's not exactly. Here I wrote the e to the x's first, and then they're trig. But you know multiplication commutes. Same exact answer. Tic-tac-toe. Did I really do all of them already? For some reason, I don't think I did this top right one, e to the x dx. Let's do that one. We have that the answer to this one is right here. E to the x times x minus 1 plus c. So, I'm going to take the derivative of x, because that's going to go to 0 pretty quickly. X, 1, 0. Integral of e to the x is e to the x. So it's plus minus. is plus that product. Look, I'm done. Is plus that product minus this product. Done. Next problem. If you want, you can factor out the e to the x like I did, but I'm done. Same answer. 1, 2, 3. Okay, clearly I did this one using the tic-tac-toe method. Or I guess I did all of them. I did this one tic-tac-toe. See how much faster it was using that method? Okay, use that method, makes life lots easier.